Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote Orifice traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
In the previous video, we discussed the conditions where orifice traps do not work. Condensate flow becomes unstable, or differential pressure becomes unstable. When either of these conditions collapses, the orifice principle no longer holds. So the next question is simple. What kind of heat exchangers allow an orifice trap to work properly? Today, I will explain this using real examples. Let me start with the conclusion. There are two key conditions. Steam consumption must be stable, and differential pressure must also be stable, or even if they change, the change must stay within a predictable design range. That is the basic requirement. Now, let us look at several examples. First example, a distillation column in a petrochemical plant. In this case, steam consumption and differential pressure are almost constant. The plant operates 24 hours a day. There are no process changes. Temperature is stable. Flow rate is stable. Steam usage is nearly constant. In reality, condensate generation changes less than 10%. Under these conditions, an orifice trap works perfectly. The same applies to many upstream processes in chemical plants, and also to various types of reboilers. In these systems, steam demand is steady, and operating conditions remain stable. Next example, a continuous heating line in a food factory. For example, a fryer line used in instant noodle production. The production line runs at a constant speed. The process does not stop. The throughput is stable. Steam consumption stays within a consistent range. That means condensate flow is also stable. These conditions satisfy the requirements for an orifice trap. The same is true for heating processes using thermal oil systems. The required heat load is determined by the operating conditions. Steam consumption remains within a predictable design range. Differential pressure also stays stable. When these conditions are satisfied, an orifice trap can work properly. Now let us look at a case that appears unstable at first glance, but in fact can still work. Processes controlled by temperature programs. For example, batch heating processes in food factories or dyeing vessels in textile plants. These processes follow programmed temperature steps. Heating, holding, cooling, all temperature changes are controlled by a program. Steam consumption is automatically adjusted according to that program. Let me explain this in a little more detail. During the heating stage, steam consumption is high. Internal pressure is also high. During the holding stage, steam consumption decreases. Internal pressure also decreases. The important point is this: condensate flow may change, but the process can still work with an orifice trap. The key condition is not whether condensate changes. The key condition is this: is the process temperature controlled by a program, and are changes in steam consumption predictable within the design range? That is the real requirement. When temperature control is programmed, changes in condensate flow are predictable. Internal pressure changes together with the process conditions. Because of this relationship, an orifice trap can often work successfully. Today we looked at several examples a distillation column, an instant noodle fryer line. But this discussion is not about industries. And it is not about specific equipment types. It is about how steam is used. The conditions for an orifice trap are simple. The process must have programmed temperature control. Steam consumption must remain predictable, within the design range, and differential pressure must remain stable. Whether an orifice trap works is determined by the steam conditions of the heat exchanger. That is why, when we visit a factory, we focus only on those conditions. In the next episode, we will discuss a very common question. People often ask, do orifice traps clog? In the next video, I will explain the reality based on what we see in the field.